Hey, this is Jason Molesky. In this example, we'll review how to use the binomial probability formula. Each child of a particular set of parents has a probability 0.25 of having type O blood. Let's suppose the parents have 5 children. We want to find the probability that exactly 3 of these children will have type O blood. And then we'll want to figure out whether or not the parents should be surprised if more than 3 of their children have type O blood. And of course, we'll want to justify our answer. Let's let x equal the number of children with type O blood. We know then that x is a random variable with a binomial distribution where n equals 5 and p equals 0.25. Recall the 4 requirements to be binomial. We have 2 possible outcomes, either the child does or does not have type O blood. Knowing whether or not one child has type O blood doesn't give us any more information about another child having type O blood, so they're independent. We do have a fixed number, 5 children that we're looking at, and the probability of each child having type O blood is the same, 0.25. We want to find the probability that x equals 3. Well, using our binomial formula, you remember we first have to start with 5 choose 3. That tells us how many different ways we could have 3 children out of 5 with type O blood. Then we find our probabilities of successes, 0.25 to the 3rd power, meaning 2 of the cases would have to be failures or not having type O blood. Probability of 0.75 on each of those, squared because we have 2 cases. Multiplying all that out, we find 0.08789, meaning there's roughly a 9% chance that exactly 3 of the 5 children would have type O blood. Now, should the parents be surprised if more than 3 of their children have type O blood? Well, if we let x equal the number of children with type O blood, we again note that it is a binomial distribution. We want to find the probability that x is greater than 3. We find this by adding the probability x equals 4 to the probability x equals 5. We could also do the probability of x being 0, 1, 2, and 3. We could add all those up and then take it away from 1, but this will be less work this way. Using our binomial probability formula then, 5 choose 4 times 0.25 to the 4th times 0.75 to the 1st would be the probability x equals 4, and 5 choose 5 times 0.25 to the 5th and 0.75 to the 0 would be the probability x equals 5. Adding that up, we get 0.01563. So because there's only about a 1.5% chance of having more than 3 children with type O blood, we'd say the parents probably should be surprised if this happens. For some additional practice with using the binomial probability formula, try exercises 75 and 77.